I don't think it's a secret that I love physics and math. I mean, just look at my last two videos. But many people don't feel the same way. Many people find physics complicated and abstract. So many unique areas and topics to explore, it leads many to be turned off at the idea of learning it. But many forget how awesome physics can be. I ask you, how would you calculate how the Earth moves around the sun, or predict how gravity behaves in space, or how you can predict future events, within reason of course? All of these are where physics comes into play. With that said, I want to explore one of the most basic areas of physics, kinetic motion, in Minecraft. Yep. To preface this pseudo-lecture, I'll be taking a lot of information from my time taking AP Physics 1, an algebra-based physics class that is currently the most challenging class I can take as a senior, besides AP Lit. But that's for uber nerds, and I'm not that. Totally not. So let's start this video from the beginning. What is kinetic motion? That refers to how we move through our 3D world. It tackles how we begin moving, stop moving, and the time it takes to do so. In this area, we have a couple of values we need to pay attention to, all of which can fit into two categories. Scalars, which just measure a given distance without specifying in what direction it goes. The values we'll use are things like distance, or how far an object has gone in a given time frame. Unfortunately, for my red-blooded Americans, distance is usually measured in meters, not in freedom units. Time, which is something I presume you know, this is usually measured in seconds, and speed, which measures how fast a given object is moving. This is measured in meters per second. And then we have vectors, which specifies a quantity, which I'll refer to as magnitude going forward, and in what direction that quantity is going. Examples of these include velocity, being just speed with direction, displacement, which is considered how far an object has moved in a specific time frame. This doesn't account for how much the object traveled to get there, and acceleration, which measures how much an object is changing velocity. This, oddly enough, is measured in meters per second squared. To add with acceleration is gravity. Gravity is an acceleration constant which is about negative 9.81 meters per second squared in the y direction, meaning an object would accelerate downwards. Whether it is accelerating or decelerating is dependent on where its velocity is pointing. These are the main values we'll use going forward. Got it? Get it? Good. Let's start with lay math importante. Notice how our velocity and acceleration have other quantities in order to measure themselves. That's not by mistake. If we wanted to find velocity and speed for a problem, we could simply divide the distance the thing had traveled by how long it took that thing to move that distance. For example, say it took me about 4 seconds to travel 20 blocks to the right of. To find my approximate velocity, we take 20 blocks and divide it by 4 seconds, giving about 5 meters per second. And to find the amount I accelerated by, I would need to find at what velocity I started with, being 0, and the velocity I ended with, being around 5. And since it took me around 4 seconds to complete, we would calculate my acceleration as the change of my velocity over how long that took me, which would give me about 5 orders meters per second squared. Of course, Minecraft has the player accelerate near instantaneously, but that's unimportant for my scenario. This possesses a question. How do we calculate all these values interchangeably? And by that I mean, if we were given distance, time, and the value of the starting velocity, how could we find an object's ending velocity? Well, this is where I'm going to introduce the three primary kinematic equations. Those are Vf equals Vi plus At, d equals VIT plus 1/2 AT squared, and VF squared equals VI squared plus 2AD. These equations have one cool quirk with them. Each of them is lacking one variable. The first one lacks distance, the second one lacks VF, and the latter lacks time. So with most questions, you can often just plug and chug until you find the answer. Very important to note, when an object is at the peak of its trajectory, the velocity of that component is usually 0. Gravity is slowing it down until there's a split second where it is stationary in the air. But here's where it becomes more complicated, because most things don't move back and forth or up and downs. They can move in more dimensions. With this said, what if we added another dimension? This is unfortunately where trig comes in. Now we are working with vectors in more specific detail. A vector in a 2D space likewise has two components, x and y. An important skill is how to split up these vectors into their base magnitudes. To do this, first find the angle in degrees at which it is off an axis, usually being the x, then take the magnitude of the vector itself and then multiply it by the sine of that angle if you're finding the y component, or by the cosine of the angle for the x component. Now this is all fine and dandy, but what if it was in 3D? Now this process gets more of that Craig Deck level of mind-bendery I find very endearing. To find the z component, find the angle off the z-axis, and then multiply the magnitude by the cosine of the angle. For a fun pulse check, why exactly is this its formula? Think about the classic abbreviation of SOHCAHTOA. Next, find the xy component before we can find the x and y components individually. So let's take the angle at which the vector makes with the xy axis, usually looking like dotted lines in most questions. If the angle is off of the x-axis, known as the azimuthal angle, probably butchering that, you'd take the magnitude and multiply it by the sine of that angle. This component I like to think of as the modifier for the following components. For the x and y, now, use the aforementioned formulas but replace the magnitude with the modifier to get your oh so precious components. So there are the x, y, and z components. They can be written like this, with the hat over them being the way physicists separate components from variables, since they can look a bit similar. To make sure you're correct, plug them into this formula and you should get the OG magnitude back within a certain margin of error because of rounding. To switch to something easier, another important aspect is adding and subtracting vectors together. This process is beyond simple. Just add each component separately. Same process with subtracting vectors. Just take each component of the second and flip the sign in front. If it's positive, it's negative, and vice versa. Now just add each component together, bada bing, bada boom. Subtraction. Why flip the second vector's sign instead of just subtracting? Well, actually, physicists don't subtract vectors, only add them when they're facing the opposite direction, so the two cancel one another out in some way, shape, or form. But the easy train ends with that, because for adding and subtracting magnitudes with an angle, you'd need to find the independent component and then add those together. After finding those components separately, plug them into the formula I showed earlier to get back a single magnitude. And to find the new angle created, simply plug in arctan of the new y component, and that'll spit out the angle of the vector. Okay, last part, I swear. A lot of physics requires a person to look at data tables. For kinematics in particular, there are three main kinds of graphs we look at, which I'll look at in just a second. A very important aspect of physics graphs are its slopes and area underneath the curve. Anyways, physics graphs include position time graphs, whose slope measures velocity and has nothing for area under curve, velocity time graphs, whose slope measures acceleration and whose area underneath measures distance traveled, and acceleration time graphs, whose slope measures nothing besides jerk, but that's outside the scope of this video, and whose area underneath measures velocity. Think of the area under the curve as being one level down from the quantity being on the y-axis, and the slope being one level up in the quantity. Now that I've explained the conceptual aspects, we can finally switch over to Minecraft. Here's a problem. A player is trying to shoot a target from 30 blocks away. Consider that where the player releases the arrow is the same height as where the bullseye is. If the player releases that arrow at a velocity of 24 blocks per second and at an angle of 45 degrees, how long would it take the arrow to fly to hit the bullseye? What would its max height be as well while traveling through the air? Consider the gravity is equal to negative 20 blocks per second squared. After you have solved, I'll include the answers in the description. So, there it is, the basics of kinematic motion. This was more or less a lecture with less Minecraft, and I apologize for that. Hopefully next video will include more Minecraft and less math and conceptualization. In conclusion, physics is pretty cool, I guess. Yeah. Anyways, hope you have a good rest of your day. Bye guys.